exterior but also the interior part of the model. So from one scanning process we can actually gain multiple parts, not only one part. Right, so it's the same for materials. We can see the composition inside the materials, and also if we have like a product, we can do an inspection whether there's a crack, whether there's a defect inside the product. Right. So right now I'm going to explain a little bit about the workflow of image-based modeling, or how Simpleware generate from 3D image into a 3D model. So firstly, where do the images come from? So the images come from the scanning process. We can use a scanner like CT scan or MRI, micro CT, fixed SEM, serial sectioning, or confocal microscopy, or other type of scanners, as long as the scanners can produce a stack of 2D images. Alright, so this is an example of a stack of 2D images, which means that from the scanning process, the scanner will give us many slices of image. So from when we have these images, we import this into Simpleware. Simpleware will be able to generate the 3D model. Okay? So if you have a scanner that can only generate 1D image, then unfortunately we cannot use Simpleware to generate the 3D model. So in order to generate the 3D model using the Simpleware, we need these few slices of images from the scanning process. Okay, so the workflow, we import this stack of 2D images into Simpleware, and then in the image we have a pixel, and the pixel will be interpolated and become a voxel grid, and then we do a segmentation or selection of region of interest. So as example, this is our product, so we do a segmentation of our product, and then we extract the segmented voxels or the selected voxels, and then we create the volume or surface mesh. Alright, so the surface mesh can be used for 3D printing as example, the volume mesh can be used for the FE or CFD simulation. Right. Good. So it's the same process for any application. So just now the one I showed is for the product, so this is like for a femur, so we have a stack of 2D images of femur. Then we will form a voxel grid, then we do a segmentation, then we extract the segmented voxels, then we can create the volume or surface mesh. So, as I said just now, we have an additional module in Simpleware. So, for meshing, we need to use the FE module. So, by using the FE module, we can do so many things. I will explain more in detail later. So, as example here, we do like mesh refinement at the femur head, we define nodes at the femur head, so that later when we export into the FEA software, we can apply loads at the femur head or constraint, etc. I will explain to you later about this, and then we can export for a simulation. So it's the same process for materials as well. So we import to Simpleware, we form a voxel grid, then we do a selection, then we extract, and then we create volume of surface mesh. Alright. So is it clear about the software? Do you have any questions? So basically what I want to show here, Simpleware is a software that convert from 3D image into a 3D model. So as long as you have a stack of 2D images, you will be able to generate the 3D model using Simpleware. Okay? Is it okay? Do I speak too fast or okay? Is it clear? Is it clear? Okay. Alright, so right now I'm going to talk a little bit where the software can be used in the industry. So these are some of the industries where Simpleware will be very, very useful. Okay, so it can be used for consumer products as an example. So consumer products, as an example, we use Simpleware to generate this 3D model of a head. Alright, and then, okay, in Simpleware, one of the additional module is called CAD model. So CAD module will allow us to import the CAD model. Okay, so as an example here, we have a head model. So we use CAD software like CATIA or AutoCAD to design this helmet. Okay, and then using the CAD module, CAD module, we import the helmet into Simpleware, and then we do the positioning to see whether the helmet is fit to the head model or not. Okay, and then for the consumer products, as example, it can be used to So the software simpleware can be used to design the helmets or protective gear, healthcare product, packaging or containers, headphones, earbuds, etc. And then the software simpleware can be used as well for life sciences. So example for medical devices, implants, anatomical simulation, human body models, etc. For life sciences, the software simpleware has been approved by FDA, Food and Drug Administrative. So which means that it will be safe to use for your research, as it has been certified by the FDA. Alright, and then it can be used as well for automotive or aerospace, where we can do reverse engineering, where we can do a crash simulation or safety study of the parts, automotive and aerospace. And then it can be used as well for oil and gas industry. So example here we have a digital rock physics, porous media, geophysics, and then industrial engineering as well to do the inspection, as I have mentioned just now. For the production line, we take one sample and scan and then see whether there's a crack inside it or not, or porous, or etc. And then we can do NDE or NDT, non-destructive evaluation or non-destructive test. Okay, by doing by creating the 3D model of a product and then doing a simulation. And then it can be used as well for 3D printing. We have a library of lattice structure that will allow us to design the infill of the 3D printed part. And then we have a materials, and it can be used as well for materials engineering. So let's say we have a composite material, then using a simpleware we can see the composition of the materials inside the composite material itself. Right? And then we can do quantification, etc. So for materials engineering, we can also create foams or filters, asphalt or concrete. So basically, as long as the model that you want to create can be captured by the scanner, then you will be able to generate the 3D model. So it doesn't matter how fine or how thin is the dimension of your model, as long as it can be captured by your scanner, then we can generate the 3D model using the software simpleware. Alright? So this is for the example for materials and energy. So for materials and energy, we can use for material characterization, composites, metals. For asphalt, concrete is example. So this is the pavement of a road. So we take a sample, we scan, we use simpleware to generate the 3D model, and then we use the FEA software to do the stress analysis, so we can see the stress distribution of the road. And then it can be used for digital rock physics. So this one, as example, we take a sample of rock, and then we scan, and then the images we import into simpleware generate the 3D model. From there we can quantify the amount of mineral in the rock. Okay, so that's one of the examples. And then it can be used as well for porous structures to study the permeability of your material as example. And then it can also be used for microstructures like fuel cells that we have here. Okay? So example here we have a composite material, so we can see the composition of the material. It can be used as well to study the composition of fibers, material. Okay, and then this is like the particles where we can create and separate the particles based on the connectivity on the void. I will show you one example for the, Okay, this is a rock core. So we take a sample of rock core from land. Okay, we drill actually and take it, and then we scan the rock. Alright, and then we use simpleware to generate the 3D model. So from the 3D model, we can separate the minerals inside the rock. And then from here, we can quantify the amount of the mineral inside the rock. So this is one of the applications how we can use a simpleware. We can study the volume, we can study the surface area, so it depends on how we want to use the software. Alright. And then for industrial engineering, we can use to do the reverse engineering. We can use as well to study the NDE or NDT, the machine inspection, manufacturing defects, and also can be used for 3D printing. As I said just now, we have a library of lattice structure for 3D printing, so you can see that we can design the infill of the 3D printed part easily using the software simpleware. And then here for inspection, we can see there's a defect, there's a crack inside this cylinder head. And then, as I said just now, the very thin layer inside the battery also can be captured, can be designed, can be modeled, etc. Okay? So this is the engine manifold example. So as I said, we scan the engine manifold, we will have a stack of 2D images. The 2D images will be imported into the software simpleware. And then the software simpleware, we generate a 3D model. From there we can see, okay, here they want to show that there's a crack. Okay? So but then it's from 2D image, it's quite difficult for us to quantify the crack. We don't know the volume of the crack. By then, so using simpleware, we generate the 3D model, and from there we will be able to generate precisely the volume of crack inside our product. Alright? So you can use as well for life sciences. So life sciences you can use to create medical devices and implant stents, and do the brain simulation as well. For anatomical simulation, human and body consumer product interaction, food sciences and also paleontology. So as example here, we have a few models that have been generated by simpleware. So as you can see here, from one scanning process, we can gain multiple parts of your body. Alright, so imagine if you need to use CAD software to design each part of the body, that will be very, very difficult. Alright, so here we have a vertebra, we have a femur, a body model, we have a brain, so everything can be modeled using simpleware. So this is a human head model. So from one scanning process, as I said just now, we don't get only the exterior but also the interior. So you can see from one scanning process of the head model, we can gain 12 parts inside the head model. It's not only one. 12 parts. Okay, we can get everything inside the head. We can get the vertebra, we can get the backbone, we can get the brain, inside the brain, we can get the eye socket, we can get eye, the flesh, the bones, skeleton, etc. Okay. And then when we use the additional module of simpleware, it's called FE module, we'll be able to mesh the model precisely, not only the exterior but also the interior. So you can see. Alright. So finish with the application. Do you have any questions so far about the applications? Before I go in detail for each modules that we have in the software simpleware. Alright. If no question, I just go straight to the next section of the presentations. Alright, so for this section I will share with you the core software that we have in simpleware and also the additional modules that we have. Okay, so the core software that we have in the simpleware is called Scan IP software. So this Scan IP is a core software. This is the software that will allow you to convert from 2D images into a 3D model. Alright, and then we have additional modules. We have 4 additional modules. The first one is a CAD module. So the CAD module will allow us to import the CAD model that you design using a CAD software, right, like CATIA, AutoCAD. And then we have an FE module. FE module is a module that will allow you to generate the mesh, and the mesh can be exported into FEA or CFD software for simulation. And then we have NURBS module. NURBS module is to generate the NURBS surface, and the NURBS surface model can be exported into CAD software like CATIA, AutoCAD, etc. And then we have a physics module that will allow us to do effective properties calculation. So let's say you have a composite material and you want to know the Young modulus of the composite material, then you can use this physics module. Okay, this is not a complete FEA or CFD simulation, but then this one is only meant to calculate the effective properties to give you an idea what is the properties of your material. Okay, this is the overview of how the software works. So firstly, we import the image data. We import into Scan IP software. So if we use the Scan IP software itself, we can generate the STL file, the surface mesh. Alright. So and then if you want to import the surface objects, which means the CAD model that we generate using a CAD software. So we need the CAD model, okay, for us to be able to import into the simple web. And then from the CAD module, we can the output also is in format of the STL. And then we have FE module, which means that we have the image data, we import into scan IP, the scan IP will generate the 3D model, and then if we want to create the mesh of the 3D model, we need the FE module. Okay? Then from there, from the FE module, it will allow us to create the volume meshes for FEA or CFD simulation software. Then we have a NURBS module to create the NURBS surface, and then can be exported into CAD model in the format of IGES. And then we have a physics module where it will calculate the effective properties. As example, like Young modulus, Poisson ratio, absolute permeability, thermal conductivity of your material. So it's based on the composition of the material that you has scanned and generated. Okay. Now I'm going to present in detail the software scan IP and also the modules that we have, right? So the first software, the first one is a scan IP software. This is a software that converts from 2D images into 3D model. So the first thing that scan IP can do is it will allow us to import the images that we obtain from scanner like CT scan, MRI, FIPSEM, etc. Okay, so the images can be imported when we have a scan IP. So the formats can be a raw image, so it can be JPEG, TIFF, PNG, as long as it is a stack of 2D images. Alright? So this is an example of stack of 2D images. And then if you use MRI or CT scan, normally you will get like DICOM images. Okay, DICOM format. And then using the scan IP, it will allow us to do the image processing. Okay, so image processing, as an example, if you have, if the images that you obtain from the scanner, from the scanning process, has a very low quality. So we have a tool that will allow us to fix the images so that we can do segmentation, so that we can generate the 3D model. Alright. Other than that, for segmentation, we have like from manual, semi-manual, semi-auto to automatic tool in order for us to do the selection or segmentation of the model that we want from the images. Okay, so we have a wide range of tools, many tools. So as it doesn't matter if your image has a low quality, which means that the contrast is low or the resolution is low. It doesn't matter because we have a wide range of tools that will make sure that the software is able to generate the 3D model. Alright, and then we have also like filters, tools to defeature, smooth, and also fix regions. Then we also have a 3D editing tools. Alright, so as example, like for these particles, we use fully automatic tools, which means that with one click, we will be able to do the segmentation or selection from these images. Alright, so this one, the particles has been segmented based on the connectivity and also the volume. So for one click, so it's very easy. Okay, so if you work with body part, we have also a tool that is called background registrations, which allow us to combine the images that come from different sources. So as example here, we have images of knee model that come from CT scan and MRI scan. Okay, this is comes from CT scanner, this one comes from MRI scanner. So we can combine these two images using the software simple. So what we do, we just need to create the landmark 1, 2, 3, 4 on both images, and then it will do the combination for us. Alright. So this one is much clearer. So this comes from CT scan, this comes from MRI, and then this is the result of the combination. So why we need two sources? So normally for body part, CT scan images is very good when we want to do the segmentation of bones, we want to generate the model of bones. But for MRI, normally it's better to generate the model of muscles or tissue, etc. Okay, so that's why sometimes we need to combine these two images from two different sources. Okay, and then we also have a 3D editing selection options. Here for the latest version, we have a frustum tool that will allow us to do like a non-uniform selection, as you can see here. Alright, and then we also have a propagate and interpolate tool. So this one is used normally when we have a low quality of image, so we have no options but then to segment it, to do the selection manually. Alright, to generate the model manually. So which means that we can't use the automatic tool. So what we do, we use a propagate and interpolate tool, which means that we need to paint on few slices and then use the automatic tool to interpolate it and create the 3D model. And then we also have a 3D wrap tool. So it's the same concept as a previous tool, but then this one we paint in 3 directions and then it will wrap and generate the 3D model. So as example for this vertebra that we obtained for MRI scan, so we paint 15 corner, 5 axial, 1 sagittal, so it takes like around 2 minutes, and then the wrap time took only around 2 seconds. So it's pretty much very easy. Okay. And then we also have a fill gaps tool. So this one, when we do a segmentation of multiple parts, so it will create a small holes like this. This one is very dangerous when we want to use the model in FE simulation or CFD simulation, because these small holes can cause very serious problem for your simulation. It can cause a crash to your simulations. So this fill gap will help you to prevent all those kind of problems. Right? And then scan IP can be used as well to do the visualizations. So we can create video, we can create images using the scan IP. So all the videos that I have shown to you just now, totally made using the software Simpleware or scan IP, which means that we don't use a third-party software to create the video. So you can create a nice video using the scan IP software for the presentation, etc. Okay, so this is for the applications. And then we can also do the reslice volume. So reslice volume, which means that we can do a cross-sectional image which is not along the axis X, Y, and Z. Okay? We can create the image along the lines as well. We can do the cross-section along the lines if it's needed. So we just need to create lines around center line of this hole, as example. Then we can do the cross-section along the lines. Okay. Other than that, we can also do measurements and statistics using scan IP. Okay, the measurements can be done in 2D and 3D. Okay, we can also create a center line. So, for example, we create a center line of this bone. Alright, from there we can measure the surface of the cross section. Okay, the surface area of the cross section. So as you can see, here, this is a cross section that we can measure the surface of it. So this is example the center line. So we can generate the center lines and we can identify the shortest distance of a porous material as example. So let's say this is a air path in the porous material. So we create the center lines and then we can identify the shortest distance in the porous material. Okay, so there are so many measurements that can be done. So as I said just now, it can be done in 2D and also in 3D. And also we have a wall thickness analysis tool that will give us information of the wall thickness. And then we also have like a shape fitting tools. So this measurement, example, if we want to measure the whole of this part, So what we need to do is just need to paint this part, and then it will generate a cylinder. So the dimension of this cylinder is the dimension of the hole, right? So it can be used as well for femur examples. So we just need to paint the head of this femur, and then it will create a sphere. So this one, if you want to create implant of the head femur, so it can be done easily using this tool. We can also measure the distance between two shapes. So, as example, if you want to know the height of this cylinder head engine, so you just need to create a plane at the bottom and plane at the top, and then you can measure the distance. So the same for femur. So we just need to paint the femur head, and then it will create a sphere, and then we can measure the distance between these two femur heads. Alright. And then using scan IP, we can export into STL file, watertight STL file, so you can use for 3D printing. And then we can also generate video, and also we can do a screenshot. So as I said, the SoundScan IP is a core software that will convert from 2D images into 3D model. Alright, and then we have another additional module. The first module is CAD module. So the CAD module, the function is to allow us to import the 3D model, and the 3D model that we generate using the CAD software. Okay, like CATIA, Top Solid, or SolidWorks, etc. Okay, so the format can be STL, IGS, and also STAT. And then in CAD module, when we import the STL file, it will check and fix the self-intersecting or non-watertight STL. So if there's a problem with our STL file, the CAD module will check and fix the STL file. So you don't need to be worried about the condition of your STL file. And then in CAD module, it will allow us to create primitive shapes, like very simple shapes like sphere, cuboid, tube, etc. And then CAD module will allow us to do a surface positioning. So if you work with an implant, then you need the CAD module to do the positioning of your implant in your bone, right? So yeah, it's the same for the engine. So let's say if you do the reverse engineering, this is the one that you have generated using Simpleware, and this one is you want to introduce the new part in your engine, then you can use your CAD software and do the positioning. Yeah, so the same. Okay, so this is very useful. Okay, this one is called surface deviation. Firstly, is a snap registration, which means that if you want to compare the part that we have scanned and also with the part that we designed using the CAD software, then we can use a snap registration. It will combine easily. And then we can see the difference by using the surface deviation tool. So it will give us the lower deviation and also the upper deviation, the highest difference and also the lowest difference. Okay? So this one is very useful, especially when you do the 3D printing. So as example, on 3D printing or you do manufacturing, so as example, you design your product using the CAD software, right? Okay? But then we know that during the manufacturing process, there are so many defects that can exist. Alright? So to see the difference between the manufactured part or 3D printed part with the model that you have designed using CAD software, you can use this surface deviation tool. Okay? Which means that you combine the two models and then see the difference. What is the difference? Alright, and then we can do a basic editing. We can do a Boolean operations that will allow us to union the two models, or allow us to do a subtraction of two models, etc. And then we can do group and ungrouping, and then we can also do a digital resurface